Good afternoon, everybody. Thank you for coming. I know we're standing between everybody and dinner and a great party tonight, so hopefully this is entertaining and well worth it. Today, myself and Kevin, we're going to talk about making penetration testing tools out of Arduinos. And before we do that, of course, we have to send some thanks to our company for sending us here, which is SIKICH. So a little bit about SIKICH is we're a consulting company, so we do lots of different things from accounting to technology installations. So what we do is penetration testers, forensics, and all kinds of different things. So SIKICH is sort of a, how do we want to say it?
Professional services. Professional
services company, yes. I haven't even started drinking yet. So about a little bit about us, the security and compliance area. So we mainly work around the PCI compliance, work a little bit with HIPAA and high-tech and all those other ones as well. But mostly we do penetration tests for compliance reasons. So if you're interested in any of those kind of services, let us know. I'll let Kevin talk about himself. He likes doing that.
I do hackery things and pen test things.
Good, thanks, Kevin. Appreciate that. Nice. Yeah. All day long it's like this at work. So a little bit about myself, as I also do hackery things. I'm on the consulting side, penetration testing. What Kevin didn't mention is he is the founder of the Mini Poner project. He decided to give that up one day and gave it over to me. Between us, we've created the Mayhem Lab project where you'll find a lot of our source code and things that we published today are out there. I like to say he's the software side of things and I'm the more physical hardware guy. So today we're going to talk a little bit, we got some background information, we're going to talk about embedded systems and then get into some of the physical SE stuff that we've done. So all these tools we've basically come up with. There are definitely professional products out there that you can buy, like logic analyzers and things like that, but we wanted to see how far we could actually push a simple $4 Arduino. So this is kind of the stack of things we came up with. And most of these we've actually used in the real world. So the basis for the talk is about the Pro Micro. So one of the big reasons, well, there's a lot of reasons we like the Pro Micro, but one of the big ones is it's very small, it's compact, it's cheap, or inexpensive, I should say. So you can get them AliExpress, yep, plug AliExpress. Get them in bulk for about $4 a piece from China. They are Leonardo clones. They're based off the ATMEGA 32U4, which is important because that helps, that emulates USB in software. So we don't have to have an extra chip on the board to do it. The other big thing that I really like about them is all the components are soldered on one side. So if you need to glue them to a project or put them in something, they can lay flat, which is really helpful. There's a couple other boards you can choose from if you don't like the micro for some reason. Obviously the legit Leonardo, a couple of the we'll see them later, but the bad USB clones that you can also get from AliExpress, or real bad USBs as well, like the rubber ducky.
So there's a couple gotchas if you've used an Arduino before but haven't used something like the Pro Micro. Because the USB's in software, you actually it configures differently in the Arduino IDE. It was designed by SparkFun, so you have to add their board's URL to the IDE, and that's under the file preferences. Once you've done that, you have to actually do Tools, Boards Manager, and add the board. And then really important, when you go to program Pro Micro or Leonardo, something like that, you have to make sure you choose the right processor. Most of the ones you'll buy are the 5-volt version, 16 megahertz. If you forget to do that step, you'll actually kind of brick your Pro Micro, and you can unbrick it with a ICSP program, which we'll talk about in a little bit. So that's one of the key things. The other gotcha with it is because the Arduino, the USB is in software, it gets a little funny sometimes if you do stuff like emulating a mouse or a keyboard, because it boots up as an Arduino, but then it quickly becomes a mouse or a keyboard, and you have to sometimes hit reset to program it. So when you start to get stuck with that, there's good tutorials online to help you through those issues as well. But they're pretty easy to get by. For almost all the demos we're doing here today, the only other components we have is like a breadboard and some wires to hook it to whatever thing we're testing. If you're doing this in the real world, you might need a soldering iron to at least solder points onto test points on your whatever target board. But yeah, if you just want to play with this stuff, you don't need that much other components.
So we're going to jump into embedded device testing, and I'm going to let Kevin keep talking.
So yeah, so the scenario here is, what if you got a little embedded device? And I'm talking about the embedded devices. If you went to any of the IoT talks over the last couple of days, a lot of those are based on like a Raspberry Pi. They're running Linux, something like that. We're talking about even lower level embedded devices. This was actually a picture of a gas pump skimmer that someone pulled out of a gas pump. You're probably familiar with the gas pump skimmers that are like a plate that goes on the outside that looks like the gas pump reader. This is actually something you put inside the gas pump. It goes on the wire between the reader and the rest of the pump. That's like a standard protocol, and people have figured that out. And if they can get that little door open, they can stick one of these in. And so the question is, okay, you're law enforcement, you get one of these, and you need to figure out what's on it, what happened, you want to pull it apart. So we're looking at, can we use an Arduino to do some things like see if there's any debug interface that we can talk to. Are there pins or other test points that give us other information? Can we store data from an EEPROM memory chip, or can we even dump the program from the device to start to disassemble that? And so one of the first tools we might use is a logic analyzer. How many people have used a logic analyzer before? So there's a few, good number here. If you haven't before, this is a commercial one. And basically all it is it's a device that you can plug up to a bunch of electrical points, test points, or pins or something like that. And you say, collect 1,000 samples or 1,000,000 samples over the next 2 seconds. And it'll tell you what's happening on those electrical circuits. Is there a data signal going up and down? Is this one always high? Is this one always low? So that's the point of it. You end up with a grid that looks like this second picture there. And we said, well, can we do that with an Arduino? Because we're trying to be cheap and we've got one on the shelf type of thing. You actually can. There's software out there. We'll see on the next slide where that came from. But if we take the Pro Micro, and really for the hookup for this lab, I've hooked a Pro Micro up to it's the backside of a card reader in this case for this demo. But hook it up to that. With the code we're using, you have to hook it up to port B, so we're on PB4, 6, the ones that are highlighted in yellow there. Once it's hooked up, then you need software. Someone has written a logic analyzer for the Arduino out there. We had to modify it for the Pro Micro. Well, somebody else modified it a bit for the Pro Micro. That's the code that you find on our GitHub site. But once you've gotten that code, you put it on the Pro Micro. Now your Pro Micro acts like a logic analyzer. Then you need some software. This SUMP logic sniffer was a software I used for that. And here's a screenshot. We don't have time for demos for all these different things. But hook it to the Arduino, run the software here, and we're able to see different pins on that card reader. What are they doing? Are there signals of interest? And then I showed the menu here where you can start to use the features of that logic analyzer software to even decode some of those signals. The limitation with this is the Arduino can't capture a ton of signals, so you're not able to capture a whole lot and do a lot of decoding, but you can at least get a look for what things look like and maybe use other devices to dig into further, which Michael will get into next.
Well, yeah, kind of. So this one we came about, so we have a device, again, like we don't know exactly what kind of interface it has, but we have discovered that it's got a TTL serial interface, but we don't really know much about it or the baud rate. So I'm fairly lazy, so I like to automate my life as much as humanly possible. So I decided to make a Arduino into figure out a way to guess what baud rate a device is running at. So main goal is you have to figure out what ground is. FYI, don't hook ground up to power. Not good. But then you put your TX and RX into pins 6 and 10, I believe it is. It's in the source code, but it'll figure out basically what baud rate you're running. So as you'll notice, I've just hooked it up to a little portable router running OpenWrt. And the image on the left shows it actually during the boot up sequence. What we discovered is it spits out things on random baud rates during a boot up sequence, which I thought was very interesting. The one on the right, you'll notice we get a 97% accuracy rate, so we're pretty positive. We only get data on one baud rate as well, so that's obviously really handy. We do have my not so live demo. But basically, I'm just going ahead, and it's got a little menu. You tap one to auto detect. It goes through, figures out, am I receiving any data on this baud rate? As soon as it detects data, it takes 1,000 bytes and analyzes it for ASCII characters. So is there actually ASCII characters there? Hits enter a bunch of times to try to get data from the system. So there we go. We've figured out that it's running on 11.5200. And it also tells you what configuration. If you'll notice, it switches pins transmit and receive, so it tries them in both directions. So then it will tell you what pins transmit, what's receive. Go.
So the next thing we might want to do is we see that the device has a EEPROM memory chip. This is actually a real thing that someone from law enforcement I was talking to had pulled apart one of these gas pump skinners, and he's like, yeah, I had to read this chip, and it's kind of a nightmare, the approach he took, because he didn't really have all the right tools, all the right knowledge, and it was the same thing I would have done at that time too, I'm sure. But seeing kind of, okay, how do we read this chip? It's actually pretty straightforward. In the real world, we would probably need to desolder it from whatever device it's on, so we can go and connect it to our Arduino. If you ever have to do that, and you're worried about destroying what you're trying to desolder because it might have data on it, look for this Chip Quick low temperature removal kit. It's like magic the way it changed the properties of the solder to have it come off at low temperature. But so we pull the memory chip off of whatever it's on, hook it up to the Arduino. We got to figure out how to hook it up to the Arduino, and so try to teach a man to fish. I'm showing you how we go about doing this, and not just how the pins would be lined up. We go and look at the data sheets. So we see that chip is a 24LC256. And it's using I2C protocol, so that's good for us to know. And we see that it's got a VCC pin, that's the voltage, the VSS pin, that's the ground, SCL, that's the clock pin, SDA is the data pin. So those are the important pins. And if we look over at the data sheet for the Pro Micro, on the left-hand side, we see that I2C is the gray box, and so they're showing SDA is pin 2, and SCL is pin 3, and ground and voltage would be as you'd expect. So you just line up and connect together that way. Once you've done that, find some code on the internet to use the Arduino to dump an external EEPROM. There's one on our GitHub site now, and when you run that, you can see it just dumps out whatever was on the EEPROM. I had written dead beef to like the 8th octet or something to test this one out. And the next thing you might do, okay, so you couldn't get the what you wanted was on the EEPROM, but you want the actual program from the embedded device. Different architecture of embedded devices do this differently. The Arduino, the AVR does this using what's called an ISCP programming header. So here, if you look at this traditional Arduino, that's these 6 pins that are on the top. It lets you do low-level programming, reading and writing the actual firmware or flash within the chip. So for us to do this, we would again use our Arduino Pro Micro as one of these programmer devices. We don't have to go out and buy an expensive programmer. There's actually in the Arduino menus an example where it's examples Arduino ISP to use your Arduino as a programmer. But like a lot of things with the Pro Micro, because it's using that different chip than a lot of the Arduinos that has the USB built in, we have to make a few changes. So we changed what pins that ISP programmer runs on. So on our Pro Micro, the clock is pin 15, MISO is 14, MSI is 16. But then if we connect that up to the appropriate pins on our target device, once we've connected that, we can use a program called AVRDude, which in this case we've told it to use -C Arduino, means use Arduino as an ISP as a programmer, -P ATMEGA 128P, so that's, or 328P, that's the actual chip on our target board on that Uno board we were looking at, and it just dumps out the firmware to a file, and we can inspect that file. I'm not going to open up that now because we've got more to look at.
Of course we do. So on to one of my favorite topics, the physical social engineering. We're all familiar with the rubber ducky, right? It's a fantastic tool. Unfortunately, it's a little bit expensive. I'm cheap and lazy. So I set out to kind of make my own. Again, there's lots of software out there already, but I wanted to tweak it a little bit. I also wanted to make it look like a thumb drive as much as possible. So this, unlike some of the other projects where we've just used, little bits of wire, I also needed a male, 2 male ends, a male USB-A and then a micro, and then basically I just soldered them together so I could plug in basically I made a really small cable, right? And I put it inside. I just kind of gutted an old cruiser drive and plugged it in. We have dubbed this the plastic chicken because it's cheaper than a rubber ducky. We'll go ahead and skip this for time's sake. The next one we did, which was kind of neat. So we've wanted to spoof magnetic cards like we do with a credit card, right? So same kind of thing that Samsung Pay will do. When you tap your phone up, it just basically creates an EM field and interfaces with the magnets in the card reader itself. So we thought that was interesting. We want to kind of make our own with an Arduino. We also found this, the reason this kind of came about is customers will have, everyone has RFID locks, right? The badge locks, the HIDs, but some customers actually still have card swipes, like an actual magnetic stripe to get in. So we wanted to figure out a way, could we spoof that, make a brute forcer of some kind. So what we have to do is, the big thing is you have to make an antenna. So you have to find some object approximately a quarter in size that you're going to be able to wrap around this wire 200 times. So I found this small liquor bottle just sitting around in my workshop. I don't know where it came from. So you wrap that around 200 times, make a nice coil. You can also dip it in this polyacrylic. You can find it at any hardware store. It just gives it a nice little, kind of like a candy coating, so it doesn't unravel, which is nice. I solder some ends on it. You connect it to the Arduino, load up the code, and then we'll see in this demo. Basically, I just have it spitting out some test data right now, but it just go ahead and spit that out. So we've got the Arduino set up. Essentially, you hook the coil up on both sides of the coil, and it pulsates it, and it sends signals through the coil in one direction and the other direction, and it simulates the ones and zeros through EM fields. If you really want to kind of take it to the next level, which we did, we created this product. I say product all the time. It's not. It's a thing. It's basically the same technology, just a little fancier. So it can hold up to 5 different credit cards. It also has Bluetooth, so it can Bluetooth to your phone, has a little menu system, stuff like that. We actually did a talk on how to build this. The link is in this slide right here, so you can go check it out if you want. It's also on our website as well. This one is it's kind of neat because it's a little bit more flexible and usable.
You can probably see the Pro Micro soldered to the board there. So
yeah.
It's kind of one of the parts.
Right, exactly, right. Which, again, gets into the whole flatness of it, right? You couldn't do that if you had surface mount components on both sides of the board like most Arduinos. The mouse jiggler, which is very similar, well, identical hardware layout to the bad USB. I didn't come up with a clever name for this, but I probably should have. The whole concept here is you're doing social engineering, and your target, maybe systems go to sleep, they hibernate at night, right, because of power savings. But you want to get into the CEO's office or financial office, whoever, plug something like this in, and it's going to randomly move the mouse around so that way the system doesn't go to sleep, and it's going to be online so you can hack into it later, right, maybe after hours, excuse me. So we used basically the same hardware, and right now the source code set up to jiggle the mouse every 10 seconds, 5 pixels in one direction, and then a millisecond later it puts it back where it was. So theoretically there should be no demo because you would never see it happen. I can't see that fast, so.
Yeah, and then our last item is RFID badge snooping. So there's a couple different approaches we might take with this. One is if you want to, could actually modify the reader, so maybe you've got access to the physical reader, or you've got your own reader and you want to make a fake one that you put on the wall next to the real one. But if you can take that reader, hook an Arduino to it, any of those readers, there's at some point on the reader at which the antenna coil feeds into the processor on the reader itself. And where that happens, they've already done some decoding. They call it envelope detection. What is the shape of the signal that's going into the processor? Well, whatever processor that is, reading that signal, your Arduino processor can read that signal as well. So that's kind of one of the approaches is let's modify a bad reader to steal codes. The other one is what if we don't have access to the bad reader, but we have access to the wire in the wall? So looking at those two different approaches, so yeah, this is the first approach where we get access to the physical reader itself. We test the board to find out where the interesting signals are, hook the Arduino up to it, you know, and find the interesting signal. So that's like output from a logic analyzer on top where we found the interesting signal. Hook the Arduino up to that point, and depending on whether it's like an EM400 board or reader, or whether it's a HID reader like your Proxmarks or Prox cards, you just need the right code on the Arduino to decode that signal. And when you decode it, you know, that's the serial port terminal I've got here. That's the actual ones and zeros that was spitting out from the card, and then that actual card number equals, you know, 2781 or whatever's there. So that's the first approach. Oops, too many people on the keyboard. And the second approach is, again, you know, these card readers, especially like the enterprise HID ones, the reader's on the door, but actually the brains are back in a closet somewhere, and there's a wire like this, you know, untwisted 6-strand wire here that goes between them. So if we can find that wire in a wall somewhere, scrape it down to the you know, individual cables and connect to them, you know, this reader's nice enough on the back. It has a sticker that shows us which color is ground, which color is data 1, and which color is data 0. And we can, what's that?
It's so helpful.
So helpful.
Yes.
So we can certainly find, you know, whatever reader, you can probably find the online documentation telling you what wires are what. And then from there, you know, download, again, the HID readers use a Wiegand protocol, so we just have to find a Wiegand protocol decoder for Arduino. They're out there. Put it on Arduino.
We have one of those. I just didn't push it to the side yet.
We got to get on the site. But there we could capture and decode the data on the way between the reader and the brains inside the closet.
So that was pretty much it. It's a very rushed tutorial of the, what did we say, 8 projects that we did? 8
different Arduino projects, yeah.
Documentation is on our website, themayhemlab.net, and then all the code that we talked about today. I know we didn't actually show a lot of it, but it's all out there on GitHub as well. We got a couple extra minutes. Got questions, comments, concerns? Yes. Well, you're welcome. No problem. I would never tell you I'm the #1 skimmer. Where did we get the idea for this? Mostly, Kevin and I like to just sit around and think of interesting things to do with crap we have laying on our desks, right? Yeah. So it's like, oh, hey, we got a pile of Arduinos. What can we do with this, right? Hey, we've got this, you know, EEPROM chip sitting here. So yeah, do we have an EEPROM reader? No, but we have an Arduino. Let's see what we can do with that, right? So we just kind of spitball and figure out what can we build ourselves. Yes. Yeah. After office hours.
And I would say, too, this is really aggregating stuff from smarter people than us. I don't know if there's anything on here other than Michael's TTL detection circuit that is something that, an idea we came up with that we could, you know, use an Arduino for RFID or use an Arduino for that. You know, we borrowed code from other people for all these projects. It's just kind of, not all of them were for Arduino and none of them for the Pro Micro, but it's kind of building on other giant shoulders.
It's like every other evolution of software, right? You take someone else's code and you modify it, and then someone's going to take that code and modify it. And so we're in there somewhere. Awesome. Other questions? No? Great. Thank you very much for your time.
I would say time to drink, but I've got to drive in the morning.
You can drive anywhere. I'm not gonna mind.
Yeah.